Hello, Year 12. Let's go through these questions. If we just go through a few, look through the test and you can see, sorry, my stand's broken for my iPad. You can see this graph here, it's a force time graph. An area under the force time graph is always the change in momentum. Another word for change in momentum is impulse. So area under a force time graph is change in momentum or impulse. And this comes up again. Where is it? Comes up again here. Another one, just the same thing. Find the area under the graph, area of the triangle plus area of the rectangle. It comes up again here, force time graph, and then it comes up somewhere here. Another one. Just is that the same? Yes, force time graph. Be careful because it's in milliseconds. That's the only thing with that one. But that's all pretty straightforward. This question here, where is it? This one, all right, so this is question 11a. Stating words how the force acting on a body related to change of momentum. Okay, so this is something you need to know. Change in momentum, rate of change of momentum. Okay, force is rate of change of momentum. I've written it down here. Okay, so why is force rate of change of momentum? Well, that means momentum per second. Okay, so if we know, as I said, there's only two formulas in this to know. One of them is this one, change of momentum equals force times time. If you rearrange that, your change of momentum per second is the force. So force is rate of change of momentum. Now, there's some things I always ask you to remember off by heart, like V equals I times R. This is one of the things you need to remember off by heart, that force is change in momentum. And a couple of questions here I'm going to ask you to email to me. The higher the speed, so this is basically, it hits an object and bounces back. So we've got a ball, hits an object, hits a boot and bounces back. And the marks are, the higher the speed, the higher the initial momentum. But the change of momentum is the same. The question tells you that. So if the change of momentum is the same and it had a higher speed, there's two options when you think about it. First option is the ball bounces back at a lower speed. So it's coming in at a higher speed, but it's got the same change of momentum. So it's going to bounce back at a lower speed. Secondly, it may not bounce back at all. It may hit the bat and it may move in the same direction as the bat. Unlikely, but it is a possibility if the speed's high enough. If you think about it, if you fired a cricket ball at a ridiculously crazy speed at a cricket bat or a foot or something, it would just knock it out of the way and wouldn't stop. Okay, so two options really with that one. And then this one here, just be careful with these. Okay, this is 12a. Collisions can be described as elastic or inelastic. You've got to be careful. Common mistake. What is an inelastic collision? Well, it's when kinetic energy is not conserved. Okay, but don't just say energy, because total energy is always conserved, as you know. We can't make or destroy energy. Okay, that's all for now, folks. You can do the rest yourself, I think.